Yes. Good morning, students. This is first PUC, important and biggest chapter, equilibrium. This equilibrium is again classified into chemical equilibrium and ionic equilibrium. Equilibrium is classified into chemical equilibrium and ionic equilibrium. Chemical equilibrium and ionic equilibrium. Very important. This is the fundamental chapter or basic chapter for your second PUC portion. If you thoroughly understand the concept of this chemical equilibrium, then in second year PUC, based upon this one chapter is there, that is a chemical kinetics. Chemical kinetics is the extension of the chemical equilibrium chapter. Be thorough with that of the chemical equilibrium first year, then in second year chemical kinetics is the easiest chapter for you. If you thorough with that of the ionic equilibrium in second PUC, electrochemistry chapter is there. Then the requirement for the electrochemistry, prerequisite of the electrochemistry is ionic equilibrium. If you perfect with that of the ionic equilibrium chapter in first year, then second year electrochemistry, for two chapters in physical chemistry, second year PUC, the single chapter is the fundamental. Be thorough with that of the concepts of this chemical equilibrium. Now I will deal with first part A. First part A, that is chemical equilibrium. Chemical equilibrium. Chemical equilibrium. See, so many reactions that occurs in nature. Some of the reactions I will give an example. For example, acid-base reactions. Acid-base reactions. That is nothing but the reaction between sodium hydroxide and hydrochloric acid. Then it gives rise to sodium chloride plus water. Sodium chloride plus water. And a few examples like precipitation reactions. Precipitation reactions. In precipitation reaction, for example, a reaction between silver nitrate and sodium chloride or potassium chloride, then it gives rise to AgCl plus NaNO3. This precipitate is formed. Precipitate is formed. Here salt is formed, here precipitate is formed. One more example, that is a combustion reaction. Combustion reaction. For example, when methane undergoes combustion reaction with oxygen of the air, then it gives rise to carbon dioxide and water. Carbon dioxide and water. Carbon dioxide and water. And some of the explosion reactions, and also explosion reactions. Explosion reactions. See the acid-base reactions, precipitation reactions, combustion reactions, and in explosion reactions. See the nature of the final product that are formed. NaCl plus water are formed. NaGNO3 and NaCl, then reaction gives AgCl and NaNO3 is formed. Combustion of methane or any hydrocarbon or any fuel or including petrol or diesel, whatever it may be, then coal, then it gives, then they gives us the end products like carbon dioxide and water and all explosion chemical reactions. In explosion chemical reactions. Then see, then backward reaction is not possible in such cases. This implies that NaCl plus H2O, the reaction between NaCl and H2O, it does not use NaOH and HCl. It does not use NaOH and HCl. These products are not formed. These products are not formed. Rather than it undergoes ionization, it gives rise to Na plus and Cl minus. Rather than it undergoes ionization reaction, it gives rise to Na plus and Cl minus. Similarly, with the reaction precipitation reactions, in precipitation reaction, whereas in precipitation chemical reaction, whereas AgCl plus NaNO3, it does not give rise to AgNO3 plus NaCl. These products are not formed. These products are not formed. Whereas the combustion of methane, it gives rise to carbon dioxide and water. Combustion of this gives rise to carbon dioxide and water. But when carbon dioxide and water then mix up, it does not give rise to methane and oxygen. Methane and oxygen. This reaction is not possible. This reaction is not possible. See the forward reaction, that is whenever the arrow mark is this left to right, that is a forward reaction, that is possible. But the backward reaction, the products that does not give back to the original reactants. Whereas in the first case, sodium chloride hydrolysis, it does not give rise to sodium hydroxide and HCl. In precipitation reaction, AgCl plus NaNO3 product side, it does not give rise to AgNO3 and NaCl. In combustion reaction, carbon dioxide and water that does not unite, it gives rise to methane and oxygen. These reactions are not possible. These reactions are not possible. But some of the reactions, consider the reactions. Consider the reactions. N2 in gaseous state plus H2 in gaseous state gives rise to NH3. Gives rise to NH3. That is also in gaseous state. That is also in gaseous state. At the same time, NH3 to give back to the nitrogen in gaseous state and hydrogen in gaseous state. Nitrogen in gaseous state and hydrogen in gaseous state. This is possible under similar experimental conditions. This is possible under similar experimental conditions. This is possible under similar experimental conditions. Similar experimental conditions. Similar experimental conditions. That is under temperature and pressure. Under temperature and pressure. Temperature and pressure. And very important, it can be carried under closed container. Closed container. Under closed container, under same experimental condition, this reaction proceeds. This is called as a forward reaction. This is called as a backward reaction. This is called as a forward reaction and this is called as a backward reaction. And by combining these two reactions, we will have N2G plus 3H2G. That is in gaseous state because, and this should be in 2 arrow marks. That gives rise to 2NH3. 2NH3, that is in gaseous state. This type of the reactions are called reversible chemical reactions. These type of the reactions are called reversible chemical reactions. Reversible chemical reactions. Reversible chemical reactions. And then in our chemistry, the reactions are classified into two types. One is called irreversible chemical reactions and one is called reversible chemical reactions. And then I can classify the chemical reactions under two titles, two headlines. Chemical reactions under two headlines. See, chemical equilibrium, chemical reactions, these are classified into two categories. Chemical reactions are classified into two categories. One is called irreversible chemical reactions. Irreversible chemical reactions and reversible chemical reactions. Irreversible chemical reactions and reversible chemical reactions. In irreversible chemical reactions, that you have an examples of acid-base reactions, acid-base reactions, that is nothing but your neutralization reactions. Neutralization reactions and precipitation reactions. Neutralization reactions and precipitation reactions and combustion reactions. Combustion reactions is nothing but burning reactions, burning with oxygen or rusting of metals and explosion chemical reactions. Explosion chemical reactions. Explosion chemical reactions. Acid-base reactions, precipitation reactions, combustion reactions are burning with oxygen or rusting and explosion chemical reactions. Now, one more type of reactions, reversible chemical reactions, what we discussed. There is a nitrogen that combines with the hydrogen, then it gives rise to 2NH3. That is synthesis of ammonia. This is nothing but synthesis of ammonia. Synthesis of ammonia. And 2SO2, this is first example. 2SO2 in gaseous state O2 in gaseous state is raised to 2SO3, that is in gaseous state. That is synthesis of sulfur trioxide. Synthesis of sulfur trioxide. Synthesis of sulfur trioxide. And one more example that I will give, that is example number 3. Example number 3, that is a 2HI dissociates to give H2 plus I2. H2 plus I2. That is dissociation of hydrogen iodide. Dissociation of hydrogen iodide. Dissociation of hydrogen iodide. That I mentioned a few examples. There is a synthesis of ammonia, synthesis of sulfur trioxide, and dissociation of the hydrogen iodide. See these examples, and in these example, acid-base reactions, precipitation reactions, combustion reactions, and explosion reactions. Here the reaction proceeds in only one direction. Only one direction reaction proceeds. Here the reaction proceeds in both directions. Here reaction proceeds in both directions. Reaction proceeds in both directions. Both means here the forward reaction and backward reaction. Forward direction and backward direction. In both directions the reaction proceeds. Such type of the reactions are called reversible chemical reactions. In a chemical reaction, reactants react to give the products. At the same time or simultaneously, the products are react to give back the original reactants. These type of the reactions are called reversible chemical reactions. But the reaction is carried to be reversible in nature. The product that should not allowed to escape. No one of the product that should be escape or not supposed to remove from the container. This implies that closed container or cylindrical containers are required to carry this type of the chemical reactions. And what about the conditions that are used to maintain in forward direction? The same reaction condition is to be maintained for the backward reaction. This implies that the temperature factor or pressure factor is to be remains constant during the reversible chemical reactions. Now, some of the examples like that of, this is about a few examples. See the various types of the chemical reaction. Now, what rate of a chemical reaction? Rate of a chemical reaction. Rate of a chemical reactions. See, some reactions are fast reactions. Some reactions are fast. Some reactions are fast or instantaneous. Some reactions are fast or instantaneous, complete within a fraction of a second. complete within a fraction of second. Complete within a fraction of second. Complete within a fraction of second. That is in the range of 10 to the power of minus 14 to 10 to the power of minus 16 seconds. Very fraction of seconds. Example, your neutralization reactions. Example, your neutralization reactions. Your neutralization reactions or precipitation reactions. Neutralization reaction or precipitation reactions. Precipitation reactions. Neutralization reactions or precipitation reactions. These reactions are called instantaneous chemical reactions or very fast reactions. Very fast reactions. Very fast reactions. Very fast reactions or instantaneous reactions. Very fast reactions or instantaneous reactions. Very fast reactions or instantaneous reaction. Usually these are ionic reactions. Usually these reactions are called ionic reactions. Ionic reactions are very fast reactions. For example, that the reaction between sodium hydroxide and hydrochloric acid that will complete within a fraction of a second, and the reaction between the silver nitrate and the potassium chloride or sodium chloride or hydrochloric acid, then the reaction seems to be a very fast reaction because the precipitates are formed when barium chloride react with the dilute sulfuric acid solution, when silver nitrate react with potassium chloride solution. Then it observed that precipitate formed within a fraction of a second, and as these type of reactions are called instantaneous chemical reactions or very fast chemical reactions. Usually these are ionic reactions. Ionic reactions are very fast reactions. Ionic reactions are very fast reactions. Now some of the chemical reactions are very slow reactions. Very slow reactions. Next one is slow reactions. Slow reactions. Slow reactions. Usually these are molecular reactions. Molecular reactions. Molecular reactions are very slow reactions. Molecular reactions are very slow reactions. Usually the slow reactions that includes reaction between hydrogen and oxygen to give a molecule of water. Reaction between hydrogen and oxygen to give a molecule of water. This is a very slow reaction. This is very slow reaction. And a few examples like that of photosynthesis chemical reaction. Photosynthesis chemical reaction. Photosynthesis chemical reaction. That is the reaction between carbon dioxide and water in order to give the carbohydrate molecule. In order to give carbohydrate molecule. Carbohydrate molecule, or even rusting process. Rusting of iron. Rusting of iron. Whereas the iron that combines with oxygen, then it gives rise to hydrated ferric oxide, that is Fe2O3 XH2O. This is called as rust. That is a reddish brown deposit. Now the rusty, immediately when an iron piece is exposed to air, it does not give the hydrated ferric oxide or reddish brown coating on the surface. See, atmosphere has carbon dioxide, atmosphere has the moisture, but in the presence of sunlight only the reaction is possible. That is because it catalyzed by means of some of the reagents that is in sunlight, that is in H2. Whereas in the dark, no photosynthesis chemical reaction is there. Therefore, hydrogen and oxygen combines to give a water molecule, or photosynthesis chemical reaction or biochemical reactions or any type of the biochemical reactions or rusting process and biochemical reaction. Biochemical reactions. Biochemical reactions. Biochemical reactions. These are very slow reactions. See the rate or velocity of the chemical reaction. Why some reactions are slow reactions and some reactions are fast reactions. Now, they are called instantaneous reactions. They occurs within range of 10 to the power of minus 14 to 10 to the power of minus 16 seconds. But in some cases, they need some of the days or some minutes, or in some cases, it may be more than that of a day. Like that, the reaction would occur. Therefore, the chemical reactions are further classified into fast reactions and slow reactions, whereas the ionic reactions are fast reactions. Molecular reactions, which are formed by means of the covalent chemical bond, they are very slow reactions. That is why even we can compare the organic reactions and inorganic reactions on the same title. Usually inorganic reactions are fast reactions and organic reactions are slow reactions. Ionic reactions are fast reactions or molecular reactions are slow reactions. Therefore, molecular reactions are very slow reactions and ionic reactions are very fast reactions. Now, what is the rate or velocity of the chemical reaction? And also, it seems to be that some of the chemical reactions that takes place in the presence of sunlight, some of the chemical reactions that occur in the dark condition, some of the chemical reactions that requires energy, some of the chemical reaction that does not require energy. In some chemical reaction, energy is liberated during the chemical reaction. In some cases, energy is absorbed during the chemical reaction. In some cases, electricity is made to pass into the solution to bring about the chemical change. In some chemical reactions, radiations are made to pass into the chemical reaction to bring about the chemical change. And the basis of these chemical reactions are again classified into different titles as light of the exothermic reactions or endothermic reactions or electrochemical reactions or photochemical reactions or radiation chemical reactions. Some parameter that is external source or external energy is required to bring about the chemical change. Without supplying these, we can't observe in time. For example, photosynthesis, it requires sunlight energy and hence it is an example for photochemical reaction. Photochemical reaction. Is it clear? Wherever in electroplating we are made to pass electricity into the solution of the electrolyte, and hence they are called as electrochemical reactions. Electrochemical reactions. Is it clear? Like that of the some reactions are associated with the liberation of the heat energy. Some reactions are associated with the absorption of the heat energy. For example, when sugar crystals are dissolved in water, then absorption of the heat energy occurs, and hence the term is called as the endothermic process or endothermic reaction. Similarly, when hydrochloric acid or sodium chloride or sodium hydroxide are made to dissolve in water, then heat energy will be liberated, and hence they are called as exothermic chemical reactions. Therefore, reactions are further classified into exothermic chemical reactions, endothermic chemical reactions, photochemical reactions, electrochemical reactions, radiation chemical reactions, and so on. Is it clear? Therefore, physical chemistry, the chemical reactions are classified in different titles. Different titles. What is the rate of chemical reaction? Rate or velocity of a chemical reaction. 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 Now consider a chemical reaction. A gives rise to product. Consider a chemical reaction. Consider a chemical reaction. Consider a chemical reaction. Suppose R gives rise to product. R means that is a reactant. R means that is a reactant. P means that is a product. A, that is a reactant reacting the product. At time t is equal to 0, at time t is equal to 0, assume that the amount of the reactant that should be 100%. 100%. 100% and the amount of the product is equal to 0%. Suppose 100 moles of the reactant or 100 moles of the reactant that is participating in the chemical reaction. When T is equal to 0, no amount of the product will be formed. As the time increases, what happens? Then suppose it is time is equal to 10 seconds, 90 moles of the reactants were present and 10 moles of the products were present. Here when T is equal to 20 seconds, then the amount of the reactant that would be 80 mole and amount of the product that should be 20 mole. As time further increases, that is equal to 30 seconds, then that is equal to 70 mole of the reactant and 30 mole of the product is formed. When T is equal to, suppose that is equal to 40 seconds, the amount of the reactant that is equal to 60 moles and amount of the product that is equal to 40 moles. 40 moles. See, as time changes, the amount of the reactant changes and amount of the product also changes. As time changes, very important, as time changes, amount of the reactant, that is R, amount of the product, that is P, both changes. As time changes, amount of the reactant R or amount of the product P both changes. Means as time increases, amount of the reactant decreases, amount of the product increases. This implies that, very important, as time increases, amount of the reactant decreases while amount of the product increases. As time increases, amount of the reactant, or you can call it as a concentration. You can call it as a concentration of reactant, or decreases. Concentration of the reactant or decreases while the concentration of the amount or concentration of the product P, concentration of the product P increases. Concentration of the product P that increases. As time increases, this is very important. As time increases, the concentration of the reactant, or that decreases while the amount or concentration of the product increases. Concentration of the product that increases. Therefore, what do you mean by change in concentration of the reactant? Change in concentration of the reactant. 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 Change in concentration of the reactant, that is delta R. Change in concentration of the reactant, that is a delta R, or change in concentration of the product. change in concentration of the product. Change in concentration of the product, that is delta P. That depends upon varies with the time, varies with time, varies with the time, that is delta T, varies with the time, that is change in time, varies with the change in time, change in, that is varies with the change in time. Now what do you mean by velocity or rate of the chemical reaction? Now what do you mean by rate of a chemical reaction? Rate of a chemical reaction. Rate is equal to rate of a chemical reaction, rate or velocity of the chemical reaction, rate or velocity of the chemical reaction, rate or velocity of the chemical reaction, velocity of the chemical reaction. Now it is given as is equal to change in molar concentration of the reactant or product divided by change in time. Change in molar concentration of the reactant, change in concentration, change in concentration of the reactant, change in concentration of the reactant, change in concentration of the reactant, that is the delta R, divided by change in time, divided by change in time, divided by change in time, that is equal to delta T. Therefore, rate of a chemical reaction is defined as change in molar concentration of the reactant, or even you can use change in molar concentration of the product also, or change in molar concentration of the product, or change in concentration of the product, change in concentration of the product, change in concentration of the product. Product means that is equal to delta P. Change in concentration of the product, it is given by means of delta P. Therefore, change in concentration of the reactant, that is delta R, or change in concentration of the product, that is delta P, divided by change in time. This is called as a velocity or a rate of the chemical reaction. Therefore, across the reactant side the concentration value decreases, across the product side the concentration of the product that gradually increases. Therefore, it is represented as plus or minus minus dr by dt or plus dp by dt. Minus sign indicates decrease in concentration of the reactant, and plus sign indicates that is increase in the concentration of the product, increase in the concentration of the product. Therefore, rate is given by rate of a chemical reaction is given by rate is equal to minus dr divided by dt dr, or rate is equal to plus dp divided by dt, dp divided by dt. Whereas a minus sign indicates decrease in molar concentration of the reactant, or decrease in concentration of the reactant, decrease in concentration of the reactant, decrease in concentration of the reactant, decrease in concentration of the reactant. Plus sign indicates increase in concentration of the product, increase in concentration of the product, increase in concentration of the product, concentration of the product. But are very important with respect to time. This is also with respect to time. With respect to time is that is a delta T with change in time. change in time. Minus sign indicates decrease in concentration of the reactant with respect to time. Plus sign indicates increase in concentration of the product with respect to time. With respect to time here that corresponds to delta T. Delta T means as that is the difference in the change in time. This is also change in time, change in time. That is why it is represented as minus dr by dt or plus dp by dt. In your exam they will ask velocity or rate of a chemical reaction is represented by velocity or rate of a chemical reaction is represented by rate is equal to rate or velocity of a chemical reaction is represented by plus or minus dc divided by dt. Where is the dc means that is the concentration of either reactant or product. Explain. In your exam they will ask rate or velocity of a chemical reaction is represented by plus or minus dc by dt. Explain the symbolical significance of plus minus dc and dt. You have to explain the significance of the dc, that is change in molar concentration of the reactant or product. Explain the symbolical significance of dt, that is the time interval, and explain the symbolical significance of the plus, that is plus sign indicates the increase in concentration of the product per unit time, whereas the minus sign that is the decrease in molar concentration of the reactant with respect to time. Therefore, that half mark, which is very important. It is a 2 mark question. Rate or velocity of a chemical reaction is represented by plus or minus dx by dt. Explain the significance of dc, dt, plus and minus. dc means change in molar concentration of either reactant or product. I am not predicting either dp or dt. It's dr. dt means the change in interval of the time, change in concentration of change in molar concentration of either reactant, change in concentration, very particular. This is molar concentration, change in concentration, very particular. Molar concentration, change in concentration is molar concentration of the reactant, molar concentration of the reactant or product P, molar concentration of the reactant or product P. dt means change interval of the time, change in 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 interval of the time. There is a plus means plus sign indicates the same, plus sign indicates the same, that is indicates increase in concentration of the product with time. That is minus sign, that is indicates the decrease in concentration of the reactant with respect to time. Plus sign already explained here. Plus sign indicates increase in concentration of the product with respect to time, that is a delta T. Minus sign that indicates the decrease in concentration of the reactant, that is with respect to delta T. This is about the symbolical significance of plus, minus, dc and dt. This is very important. Now what about velocity or rate of a chemical reaction? Velocity or rate of a chemical reaction is nothing but change in molar concentration of the reactant or change in molar concentration of the product divided by the time required to bring about the change, or the time interval that bring about the change, time interval bring about the change. Now, what do you mean by rate of a chemical reaction? Rate of a chemical reaction. Rate of a chemical reaction is equal to, it is the ratio of change in molar concentration of the change in molar concentration, most precise word, change in molar concentration of the reactant, change in molar concentration of the reactant or product, change in molar concentration of the reactant or product, divided by time interval to bring about the change, time interval to bring about the change, time interval to bring about the change, bring about the change, time interval to bring about the change. That is equal to delta R plus, that is minus dr divided by dt, or plus dp divided by dt, velocity or rate of a chemical reaction that is present. Now what is the unit of velocity, unit of rate or velocity of a chemical reaction, unit of rate or velocity of a chemical reaction, velocity of a chemical reaction, velocity of a rate of a chemical reaction. What is the unit of numerator, unit of molar concentration? This is unit of molar concentration and unit of time. Unit of molar concentration, unit of molar concentration, unit of molar concentration, that is nothing but amount of substance, that is in terms of moles, divided by unit volume. Amount of substance, usually it is expressed in terms of mole. Amount of substance in mole divided by volume of the container, usually it is expressed in terms of the moles. Amount of substance in mole means mole divided by, that is equal to liter or cubic decimeter, either in terms of liter or cubic decimeter. This is unit of molar concentration. You know about the unit of time in SI system, unit of time in SI system, unit of time in SI system, that is second, that is in second unit, that is equal to small letters. Therefore unit of rate or velocity of a chemical reaction is given by, this is moles per cubic decimeter per second, moles per cubic decimeter per second. This is usually expressed in terms of moles per cubic decimeter per second, moles per cubic decimeter per second. It is the unit of velocity or rate of the chemical reaction. If suppose the reactants or products are in gaseous state, then usually the concentration is expressed in terms of the bar or atmosphere pressure. Therefore bar per second or atmosphere per second, that is the unit of velocity or rate of a chemical reaction, where both reactants or products are either reactant or product that is in gaseous system, either reactant or product in gaseous system. This is very important in one more question. Usually they are asking, mention the unit of rate or velocity of a chemical reaction. Unit of velocity or rate of a chemical reaction is moles per cubic decimeter per second. If reactant or product in gaseous state, if reactant or product in gaseous state, unit is unit of rate or velocity, unit of rate or velocity of the reaction, unit of rate or velocity of the reaction, unit of rate or velocity of the reaction is atmosphere per second or bar per second, because we are expressing the concentration of the gases in terms of partial pressure. Pressure of the unit is either atmosphere pressure or bar pressure. This is whenever the reactants are produced in gaseous system. In remaining all other cases, we are expressing in terms of moles per cubic decimeter per second. Is it clear? Now what is the rate or velocity of a chemical reaction? Rate or velocity of a chemical reaction is the change in molar concentration of either any one of the reactant or product with the unit time. That is equal to change in molar concentration of the reactant or product divided by time interval to bring about the change. The unit of rate or velocity of a chemical reaction is moles per cubic decimeter per second. If suppose the reactant or products in gaseous state, then it is atmosphere per second or bar per second. Is it clear? Thank you.